Hello and welcome to part two of completing the square video lesson. So here we're going to pick up with example 5. And in example 5, we see that we have x squared plus 18x minus 3. Well, we know that minus 3 here is not going to help us to complete the square. The number that we really want that to be is going to be taking 18, which is the b. So 18 divided by 2, which is 9. And then 9 squared, which is 81. So we want this to be add plus 81. So we're just going to go ahead and add that 81 here. We're going to push the minus 3 out, and then we're going to subtract 81. And again, remember that adding 81 and subtracting 81, that net difference is 0. So we're not changing the value of the expression. We're just changing the format or the look of it. Okay, now if I combine these two like terms, I get negative 84. And then the trinomial inside the parentheses, that will factor to become x plus 9 quantity squared. And we're getting that from this portion right here. So whatever b was, we take b divided by 2, and that gives us what goes inside of this set of parentheses. So let's see here. So back to this example. So whatever b was, divided by 2, which is 9, goes inside of those parentheses. Okay, now let's look at example 6. So negative 14x plus 5. We know this isn't a perfect square because of the plus 5. What we really want it to be is we want it to be negative 14 divided by 2, which is going to be negative 7, and then negative 7 squared, which is going to be positive 49. So we really want this to be a plus 49. So we're just going to go ahead and add the 49 in here, push the plus 5 out to the edge, and then we're going to subtract the 49 here. Then if I combine these two like terms, I get negative 44. And then the perfect square trinomial here is going to factor to become x minus 7 quantity squared, and then the minus 44. Now, the whole reason we're doing this, completing the square, is because we're getting these expressions here to be in vertex form of a quadratic function. And remember, the vertex form of the quadratic function helps us to graph that quadratic equation more quickly. So what did we notice about each of those functions? They are in vertex form of a quadratic. And why are we completing the square? Well, it helps us in that form, vertex form. It helps us identify the vertex of the parabola and some other features. So let's use that same idea on letter A here. So it says graph the following quadratic equation. And we know that this is not in vertex form of a quadratic. This is actually in standard form. And we know that this is not a perfect square trinomial. And what we really want this to be, instead of plus 18, what we really want it is to be half of the b term. So b is 10 in this case. So half of 10 is 5, and then square it. So 5 squared is 25. So I really want this to be plus 25. So I'm going to go ahead and show that here. Adding 25, we're pushing the 18 out, and then we're subtracting the 25. And again, adding the 25 and subtracting the 25 helps us because it's like a net difference of 0. So it doesn't really change the value of the expression. It just changes the format or the look of it. Now I can combine the like terms here to give me negative 7. And this trinomial that's left is a perfect square trinomial. So it will factor to x plus 5 quantity squared minus 7. Now, this expression is in vertex form of a quadratic. So now we can use this to find the vertex, the A, and we can use that to have our ratio between the dots. So the vertex, we know, is negative 5, negative 7. So that's going to be this blue dot on the graph. Then we know that A is going to be positive 1 because here the A is supposed to be next to this parentheses, which means our ratio between the dots is going to be 1, 3, 5. Okay, so the first set of dots from the vertex, since this is an upward facing parabola, is going to be out 1, up 1, or out 1, up 1. So I'll put those two dots in there. Then the next part of the dots is going to be out 1, up 3, or out 1, up 3. So I'll go ahead and label those dots. And then the last part of the ratio is going to be out 1, up 5, out 1, up 5. So we're going to have the 2 dots there. And then we just simply connect those dots with a line. My line's not the greatest, so this is what the parabola should look like. And then example B, here again, we're given a quadratic function in standard form, and we want to graph this. So in order to graph it quickly, we need to get it into vertex form. And to get it into vertex form, we've got to complete the square. But adding 11 here is not going to complete the square. So we need to take the b term, which is -6, divide it by 2, which is -3, and then square it. So -3 squared is +9. So we're going to go ahead and add that 9 in here. We're going to push the +11 out, and then we're going to subtract the 9. Then we're going to combine like terms. 11 and -9 combine to be +2. And then this perfect square trinomial will factor into x minus 3 quantity squared. And then the +2 just tags along. So now we have this function in vertex form of a quadratic. And just by looking at this format, we know that the vertex is going to be at the point 3, 2, which I've already put on the graph here in blue. We also know that a is 1 because a is next to the parentheses there. And since it's positive, it's going to be an upward-facing parabola. And we know the ratio between the dots is going to be 1:3:5. So now I'm going to use that to go out 1, up 1, and out 1, up 1. So that's my first set of dots. Then I'm going to use the 3 to go out 1, up 3, out 1, up 3. So that's my second set of dots. And then I'm going to use the 5 in the ratio to go out 1, up 5, out 1, up 5, which I didn't do because it's kind of off the graph at this point. But you can connect the lines or connect the dots with the parabola. And that concludes our video lesson.